Okay, thanks, John. I'm Eric Day, product manager at Caringo. And as John said, we are a cluster of hardware nodes that are put together to form the storage system. The most common question we get is, how do you scale the system? And I'm going to show you how easy it is to scale our system. It's literally powering up nodes, and I'm going to show you this from the administrative screen, and also then go turn on a node. Okay, so I'm starting out from the administrative screen within our user interface, and let me give you a quick tour of the dashboard here before I go power up a new node and join it to the system. The dashboard starts out with an overview of the most important things you need to know about this cluster at the moment, and it's basically telling me, because I see all green here, that this cluster is in good health. Were something wrong, which I will demonstrate in follow-up videos, you'll see additional information here. But the basic dimensions of this cluster right now is that there is one subcluster. It's organized into 3 hardware chassis, and I've got a total of 48 disk drives across those 3 hardware chassis within the system. This cluster does not yet have much space in it. As you can see, there are 41.6 gigabytes of the nearly 250 terabytes that are available. So there's nothing registered here yet. But as the cluster space grows, this will come around here. Clockwise, it will go from green to yellow to red as your cluster fills. We've also got a look at the stream index, which is memory that is used to track objects within the system. Again, like the disk drive, this is not very utilized at the moment, so it's showing 0% still. As I continue down the system, I'm going from what are the main consumables of the system, so disk space and RAM, and now I see the status of the various components of the system. So I've got a search feed set up, which we'll talk about later, and I can see here that there is a queue of events right now, but this queue is processing, and it's just fine. It would turn yellow or red if there were a problem here, but I get an idea of the activity going on in the system. As I move further down here, I can see client activity within the system. This cluster has had a little bit of activity within the last couple of days, and we can see right here that we've got activity that's ongoing currently in the system. And I can see the types of the breakdown of the type of activity, as well as the response codes that are going back and forth to the clients in the system. And so with that, we've got summarized, we've got 3 hardware chassis currently in the system. We have approximately 250 terabytes worth of disk space available in the system. And I'm going to now go add a new node to the system by racking it and powering it on. So, having said that, let me go do that now.
What Eric is going to demonstrate here is the addition of a new server to the system. He's already racked it, so he's in place. We can go to the board and cable it up. Now that the new system is wrapped in place, Eric is going to cable up the current port, a video cable, a USB cable for keyboard. Make sure all the power and network cables are plugged in appropriately, and then he'll boot the system to join the cluster. The server goes through its normal post. You'll notice that the system is designed not to use really neat, simple data. Model display form splash. A form image is going through its normal boot procedure. As it goes through this process, you'll notice that it's not different things that are certain availability. We also use a robust process of entropy generation to make sure that our reading IDs are unique. At this point, the node is online and ready for use in the cluster. And the provisioning process is complete.
Okay, I'm back. So you saw how difficult that was to turn on the power button in order to bring a new node in the system. So now we're going to take a look at the console and we're going to watch it join. So you can see now that we've now gone from 3 chassis in the system, and we're still showing 48 disks because those disks are just now coming online, but you can see that the chassis is joined, and here shortly the disk drives will also become available, and we'll see the storage space reflect that. Okay, so now the disk drives have also come online, and you can see that we've got 4 chassis, 64 drives, and you can see that the storage space has now increased from 250 terabytes to 330 terabytes. You can also see that the RAM index, the stream index, has also increased in available capacity. This whole time, there has been activity going on in this cluster, and so it has continued to take requests from the clients in the system, and they are still processing without having to make any changes. They are just now using the additional node and the additional drives that are in the system. Okay, so let me come over to the view of the actual list of the hardware that's in the system. So I've said there are 4 chassis showing on the dashboard, but let's get some details about each of those chassis in the system. So to recap, there are 4 chassis in the system. I can see the dimensions of each of those. Each has 16 volumes. I can see the storage that is in use and available for each one of them. You'll see that the new node, the new chassis added to the system, has already received some storage on it. This is from a combination of the client activity that's going on, as well as then a background activity of load balancing, where the existing 3 chassis will start to send some of their content over here to the new node in order to begin automatically balancing it out. Something that is different about our cluster is that this is now taking place automatically. There's nothing for me as a storage administrator to do other than hit the power button and bring the new hardware into the system. The system will now adapt and take care of it, and will balance out load and balance out storage to the new hardware that was introduced. Let's take a look at one of the existing hardware boxes that's in the system. So again, at the top is a summary, 16 drives, the amount of storage in use and available, and some additional information about it. There are now additional details that you can see here, where you can see the actual drives themselves. You can tell information about them in terms of the manufacturer of the drive, the serial number, the firmware version that's running on that, as well as our internal identifier, which we call the volume ID. Each volume within our system gets a unique identifier assigned to it, and it keeps that identifier for the life of the disk drive in the system. That allows the cluster to track those drives throughout the system, even if they are taken out of one physical hardware chassis and put into another, if that were necessary because of some operational need. So scrolling down here to the list, we can see all 16 drives in the system. If I have a drive that goes bad, or when I have a drive that goes bad, because they all will wear out at some point, I have the ability here to use our volume identification to turn that on so that it'd be easy to find and locate that, and replace it within your data center. I also have the capability here of turning all the drive lights on. And then I've got some maintenance operations here for the cluster, such as to restart the nodes, to shut them down, or to retire. And we'll talk more about retire here in a moment. Okay, so you saw what was involved with adding a new hardware chassis, a new storage into the system. I want to point out that the only thing we had to do was to rack it, stack it, and power it on. You notice that there was no additional operating system setup that was necessary. There was no lengthy configuration required in order to introduce that node to the other nodes in the cluster. And we feel that's a very big differentiator, because rather than spending an hour or more, imagine if I needed to add 10 nodes at once to the system, or if I needed to add a rack or 2 racks or 3 racks to the system, the process would have been the exact same. Rack them, stack them, and power them on. There's no complex, sophisticated additional configuration required on my part. There are no additional software packages needed to manage that configuration. It's simply just power them on.